So any question from last time? Yeah, I did attendance right now. I think, yeah. Okay. So today we will talk about the exponent and radicals. It is 1.2 exponent and radical. No one has a question from last time before we start the section about real numbers for 1.1? Perfect. If one has a question, you can ask me a question. Yeah, I took the attendance. Let me take the attendance again one more time. But next time I will take it at 8 or 2. I'm not going to take it twice. Okay. So first things in this section, I'm going to talk about the integer exponent. Integers exponent. I started a brief last time about the integer exponent. I'm going to post the record today or tomorrow morning. I said about the integer exponent, if I want to do like a product of identical numbers, it will be written as something like that. Like for example, 5 times 5 times 5. This is equal 5 to the power 3. Look, the 5 and the 5 and the 5, all of them are identical numbers. So I can write the product of identical numbers as exponent 5 to the power 3. So, and I said, I give like the definition of the exponential integer. So the exponential expression. So for example, if a is a real number, and n is a positive integer. What is the positive integers? What's the positive integers?
Numbers greater than 0.
Greater than 0, like 0, 1, 2, 3, 4, 5. What about 1/2? Is integer positive? Is a positive integer?
Yes.
1 point.
No,
1/2 is not integer.
Non-integer.
It's not integer. So the positive integer, it looks like from 0 to infinity, but the integer numbers like 0, 1, 2, 3, 4. This is all of them are positive. Positive integer. The 0 is not positive integer. So all of them are 1, 2, 3, 4, 5, 6, 7 to infinity. Okay. This is the positive integers from 1 to infinity. So if I have a real number and n is a positive integer, I can define something like that, a to the power n, as a times a times a times A such that this is n factors, and I can define A here as a base. This is called base, and n here, it's called the exponent. Okay. So I'll give you example for that. Last time I gave this example, but like what is 2 to the power 4? How can I expand this? What's the answer? 2 times 2 exactly. 2 times 2 times 2 times 2. And the answer is 16. Yes. Another example. Minus 2 to the power 3. What is the answer? Minus 8. How you think about this one? How you think? Minus 2 times minus 2 times minus 2. Minus times minus times minus is minus. 2 times 2 times 2 is 8. What about something like that? Minus 3 to the power 4. What's the answer? Same idea. Minus 3 times minus 3 times minus 3 times minus 3
Positive 81.
is
Positive 81.
positive 81. What about minus 3 to the power 4?
Negative 81.
Negative 81. That means we apply the exponent 4 to everything inside the parentheses. But here the exponent 4 we applied only for the 3 and we keep the minus outside. I explain it more. This is like minus 3 times 3 times 3 times 3. But minus is outside. The answer is negative 81. Okay. Any questions so far? Okay, let's go to the next slide. Okay, so here we're going to talk about the 0 and the negative exponent. So again, if I have a real number a, but this real number is not equal 0, is not 0, is a real number but not 0, and I have an positive integer. So I have to know a to the power 0 is equal
1.
1, always 1. So any real number, this real number is not 0. To the power 0 is 1, always. What about a to the negative n? What's the answer?
Will be 1 over a n to the power
1
n.
over a to the power n. So we flip this one, we flip it, and we make the negative exponent as positive exponent, 1 over an. Okay, let's see a give example for this one. Like for example, 3 to the power 0. What's the answer? What's the answer? 1, always 1. Okay, square root of 2. No, I'm not going to talk about square root now. What's the answer for minus 3, or minus 4 to the power 0? Is
1.
1, always 1. Minus 6 to the power 0. 1. Minus 100, positive 100 to the power 0 is 1. Always 1. Okay, what about something like that? X to the power minus 3. What's the answer? By using this notation. X to the power minus 3 is
1 over s to the third, to the
to
cube,
the
I mean.
third, the positive, see, not the negative. 1 over x to the power 3, or 1 over x cubed. What about x to the power minus 5? Same idea. 1 to the power x to the 5. What about something like that? 3 to the power minus 2. What's the answer?
1 over 9.
1 over 3 square, and 3 square is 9. Any question? Okay. So again, any real numbers to the power 0 is always 1. Any real numbers to negative power is equal 1 to the positive power. Next slide. I give you some rules for the exponents. For first rule said, number 1, if I have a to the m times a to the n, this is equal a to the sum of the exponent. Why? If I have the same base, a and a, different exponent, a to the m and n, we make it the same base, we sum the exponent. Example, if I have, for example, 2 to the power 2 times 2 to the power 3, what's the answer?
2 to the power 5.
5. We do sum for 2 plus 3. And this is 2 plus 3. And they give me 2 to the power 5. What is 2 to the power 5? What is 2 to the power 5?
64?
What is it? No, it's
Wait, 32. I mean 32.
32. Okay. First rule is clear. Second one, if I have a to the power m over a to the power n, then this is equal a to the power m minus n. If they have the same exponent, if they have the same base, different exponent, and we divide it to each other, this is equal a to the m minus n. Example for that. If I have 2 to the power 3 over 2 to the power 2, what's the answer?
2.
It's 2 to the power 1. Why? Because 2, 3 minus 2. And this is 2. 3 minus 2 is 1. And this is 2. Rule number 3. If I have a to the m, all of this to the n, we do multiplication for the exponent. It's equal a m times n. Example. 2 to the power 2, all of these to the power 3. This is exactly like 2 to the power 2 times 3. And this is equal to 2 to the power 6. Okay. Number 4. Any questions so far for the first 3 rules? It's clear, right? Okay. Here, if I have different bases, a times b, and all of these to the power n, is equal. We distribute the exponent inside the parentheses. This is equal a to the power n times b to the power n. Example. If I have, for example, 2 times 3, all of this to the power 4 is equal 2 to the power 4 times 3 to the power 4. Number 5. If I have something like that, a over b, all of them to the power n, this is equal a to the power n, okay, over b to the power n. I give example. If I have 2 over 3, all of these to the power, for example, 4. Same thing, 2 to the power 4 over 3 to the power 4. Number 6 said, if I have a over b, all of these over to the power minus n. This is exactly
Reciprocal.
b over a, all of this to the more n. We flip inside the parentheses. Okay. Example. Like if I have 2 over 3 the power minus 2. This is exactly like 3 over 2 to the power 2 positive. Last one, 7. If I have something a to the power minus n over b to the power minus m, what is it equal? I flip b to the power m over a to the power n. Okay. Example. 2 to the power minus 2 over 3 to the power minus 5. What is that equal? 3 to the 5 over 2 to the 2. This is the 7 rules with their examples. Any question for this 7? Make sense? Okay, by using these rules, I can go over something it's called simplifying expression. So let's go to simplifying the expression. Simplifying expression. So first, I will explain that by example. First example said 2a to the power 3 times b to the power 2. All of these to the power 2 times 3ab to the power 4. All of these to the power 5. So when I start thinking for example like that, and the question is simplifying, first thing I started from this term, then I simplify the second term, then I multiply everything what I have, what I get. So first things I simplify the first one, 2 to the power a3 b squared, all of this to the power 2. So how can I simplify this one?
We square the 2. We multiply the exponent of 3, a to the third and b to the square.
Okay, so we distribute the 2 exponent to everything inside, right? This is the first thing. So I mean 2 to the power 2 times a to the power 3, everything to the power 2 times b squared, everything to the power 2. What is the answer? 2 to the power 2, it's 4. A to the power 3 times all of these to the power 2 is, what's the answer? A to the power what?
6.
6? Yes, it's 6. We multiply the 2 by 3 by using this rule. A to the m, all of these to the n, this is mean a to the m times n. We multiply m by n. So here a to the 6, 3 times 2, times b again, 2 times 2 is 4. So this is the first simplifying for the first term here. Second term, 3ab to the power 4, all of these to the power 5. Again, we distributed the exponent inside the parentheses. What does that give me? 3 to the power 5, a to the power 5, and b to the power 4, everything to the power 5. What's the answer? Again, 3 to the power 5 is what is the 3 to the power 5?
243.
243, exactly. For people who don't know how we get 243, this is mean 3 times 3 times 3 times 3 times 3. 5 times 1, 2, 3, 4, 5. And the answer is 243. So again, times a to the power 5 times, here again the same idea like before, b 4 times 5 is 20, b to the power 20. So right now I get two terms are simple. Now we have to multiply this thing by this one. So 4 times a to the power 5, I mean to the power 6, b to the power 4 times 243 times a to the power 5 times b to the power 20. So I make all variables, they have the same base together, and the other with the same, and the numbers we multiply together. So 4 times 243 is
972.
how much?
972.
972. So we multiply 4 with 243 and times a to the power 6 times a to the power 5 times b to the power 4 times b to the power 20. And again, like he said, 972 times. Now we have the same base, a and a, but different exponent. So we're doing summation for the exponent. What is the answer? A to the power?
A to the 11th.
To the 11, exactly. Times, we have also 4 and 20 is 24. So this is the simplest form for this expression. Any questions so far? Okay. Let's do another one, another example. Okay. Example 2. Simplify the expression, look like x to the power y, x to the y, all of these to the power 3 times y squared x over z, everything to the power 2. So again, how I start thinking for this one? By using the same idea like before. I starting from this term, I simplify it. I go to the second term, simplify it. Both of the answer I multiply together. So x over y, everything to the power 3 is equal. What's the answer?
X to the third and y to the third.
To the third, x to the third over y to the third. That's it. Second one, y square x over z square. Again, what we're doing here, we distribute the 2 inside for every element inside, for every variable inside. So what's the answer?
Y to the
What?
fourth x to
Y to the 4th
x
x to the
squared over z squared.
square over z square. Now we multiply this one by this one. So I get x to the power 3 over y to the power 3 times y to the 4 x to the 2 z to the 2. What is the answer? I make it one fraction.
X to the 5 y over z squared.
Because x has the same, here they have the same base, so x to the 5, we do summate, we sum 3 and 2. Y to the what? To the 4, right? Down, y to the 3, z to the 2. I can simplify this one by this one. How? Like I said before in the rule, look to this rule here. This one, second one. A to the m over a to the n is equal a to the m minus n. Go back here. I have this one. The same base, different exponent. This means x to the 5 times y to the 4 minus 3 over 6 squared. This is equal x to the 5. 4 minus 3 is y over z squared. And this is the simplest form for this question. I can simplify it more by making the z square goes up. We move this one up. How can I move it up? X to the 5 times y times what? Z
To the negative 1, negative 2.
Negative 2, exactly. Any questions so far? Anyone has a question? Okay, let me give you another, yeah, Jessica. Yeah, both are accepted. You can simplify. This is simple form and this is simple form too. Y negative 2. Look to this rule here. Here, when I move this up, I actually make it like the power are negative. And I do the same things by power 1. But I will give you another thing. How I think about this. I give things. Anything of the form look like this. 1 over a to the power n, and here is positive. This is equal exactly like a to the power minus n. The negative power, like I said before. Here, for this one, this is actually look like x to the 5 times y times 1 over z squared. So the z squared here is 1 over z squared. We're using the same rules like here, like this one. So this is equal x to the 5 times y times z to the power minus n minus 2. Okay? Any question? Okay, I'm going to give another example. I hope this is clear. Example. Simplifying this thing, y to the power 3z square, everything to the power -2. So look here, -2. Which rule are similar to this one? Go back to the rules. If I see something negative, look, number 6, a to the b, all of this to negative n. That means we flip inside the parentheses and make it positive power. Number 6. Okay, let's go back to the example. We have -2. This is mean we flip everything inside and we make the exponent positive. So this is mean 3z square over y, everything to the power 2. Okay, so now it's easy because we can distribute the exponent inside the parentheses 2 to everything inside. What does that equal? 3 to the power 2 times, like before, z square to the power 2 over y to the power 2. Again, 3 square is 9 times z to the, by using rule number 4, z to the 2, everything to the 2. This is mean we multiply z to the 4 over y to the 2. If I want to simplify it more like previous question, previous example, this is equal 9 times z to the 4 times y to the -2. It makes sense? Any question? Anyone have any questions? Okay, let's go. Okay, let's go to radicals now. So for radicals, we have to know anything look like this. Square root of a, for example, if I have square root of a equal number b, this is actually mean b, we square both sides. B square equal a, b square equal a. And we have to know b are positive number, positive or 0 too. And in the same time, a here also positive or 0. Second things we have, I give example for that before I go to second one. Like, what's the square root of 16? Example, it's 4. What does that mean? How you think about this one? You said 4 square, 4 to the power 4 to the 2. See the 2 here? Here actually we have 2. 4 to this power, 4 to the 2 is actually equal 16 inside the radical, inside the root.
Also, we
And
can
at the
say
same time,
16 to the power of 1/2.
15, 16 do you mean, no?
Yeah,
Yes,
16 to the
exactly.
power
The
of
power
1/2.
1/2. Yes, this is equal 16 to the power 1/2. Same. And actually, look, 16 is positive. The 4 is positive. Why? Because the 2 is even. And look, 4 is greater than 0. And also 16 is positive or greater than 0. So I'm going to define the nth root in general. I'm talking here for the second root, for square root. I'm going to talk about in general nth root. So I'm going to give you the definition in general. So the nth, so definition. So n is positive. Positive integer. Again, the positive integer is 1, 2, 3, 4, 5 to infinity. The nth root of a, the nth root of a, it's look like this here. N a is equal b. What does that mean? Like here, like before. This is mean b to the power n, b to the power n, this n is equal a. And we have to know if the n here is even number, must a and b are positive. Like if n is even number, you know the even number, right? Like 2, 4, 6, 8. This is even numbers. 10, 12, 14, 16. All of these are even numbers. The odd numbers are 1, 3, 5, 7, 9, 11. So if n here is even number, then a must be a and b here. B must be positive or 0, and at the same time a must be positive or 0. This is general definition. So I'm going to give you a more example how you think about this one. Can I go to the next slide? Let's go. Next slide. For example, where is the square root of 81? You said, what's the square root of 81? What is 2 number if I multiply? What's the number if I raise it to the power 2, they give me 81? It's 9, exactly. Well, you said 9, that's true. Why? If I want to think like this, 9 to the power 2, they give me 81 inside, and this is good, this is right. And because 2 is even number, 2 is even number, this means number 9 and number 81 must be positive. Okay, so look, the 9 and the 81 is positive. What about something like that? What's the answer for something like that? Minus 8 to the power 4. What's the answer? What is the answer here?
On the farm?
Yeah, undefined, exactly. This is true. Perfect. Undefined. Why? Because the 4 is even number. And how is inside is negative number? Like I said before, if it's n is even, must here be positive. Okay. So some properties, here your properties. It makes sense. Any question before we go to the properties? You know why it's undefined? Because here 4 is even number. So here must be positive. Some properties for radicals. So first property said, if I have the nth root a times b, I can write it as the nth root of a times the nth root of b. Example, if I have, for example, there's 2 root of minus 27 times 64. Here, look, it's odd number, so I don't care if it's even or negative, if it's positive or negative inside the root. So here, what is that equal? By using this property, I can use this property. What is that equal? Third root for what? Minus 27 times third root for what? For 64. I can simplify it and I can solve it. It is equal minus 3, like Angel he said, that's true, times 4 is equal minus 12. Look, again, here it is, the number 3 is odd. Doesn't matter inside, positive or negative, I don't care. Second property said if the nth root of a over b is equal the nth root for a over the nth root of b. So if I have dividing, I can make it like this. Example, the third root of 27 over 64. What is that equal? Same idea, exactly. So this is equal to the third root for 27 over the third root of 64. Again, 3 over 4. Number 3, if I have the nth root of the nth root of a, what is that equal? Root inside root.
We multiply the n and m.
Yes, we multiply the m by the n and make it one root. M times n of a. Example, third root of the second root or the square root of 9. What's the answer? We multiply 3 by 2, right? Give me 6 of 9. Any question for these 3 properties? Okay. So now let's go to the fourth property, the last one. Number 4. It said if I have the nth root of a to the power n. Look, a nth root of a to the n. So this is equal to things. This is equal to things. Equal a if n is odd, and equal the absolute value for a if n is even. What is the absolute value? What is the absolute value? Anyone know what's the absolute value?
The relation from the 0 to the number.
What is that? Can you repeat what you said? Hamir Ahmed, he said the distance from 0. This is true. But let me give you more like explanation for the absolute value for a. Absolute value of a, they give me always the positive number. They give me always the positive. I change the sign for a to the positive a. I make a positive. Like for example, the absolute value for 3 is 3. The absolute value for -4 is 4. I can define it as a minus a. If a is positive number, if a is negative number. I multiply the number by negative if it's negative. If it's positive, I keep it the same thing. For example, the absolute value for -6 is 6. So again, go back here. If n here, look, if n is positive, is even, then the answer must be positive. How can I make it positive? By taking the absolute value. If n is odd, doesn't matter what is a. If it's positive, I keep it positive. If it's negative, I keep it negative. Make sense? Give you example for this property. What is, for example, the third root of -3 to the power 3? Look, a 3 here is odd number. That means the answer will be under this power, -3. Doesn't matter if it's even or it's odd. If it's negative or it's positive. Why? Because the 3 is, let me change it to 3. I don't want to use the 3 because I want to make it explain more. I will use 7. Here, 7. 7 to the -7 to the 3, the answer is -7. Why? Because the 3 is odd. a power 3. What about this one? 4 and here minus 7 to the 4. Because the 4 is even the absolute value of minus 7. The absolute value for minus 7 is 7 because number 3, number 4, the power 4 is even. Even number, odd number. It makes sense? Any questions so far? One has a question, you can ask your question. Okay, let's give example, more example, or simplify. Does that apply to all even and all odd numbers? Yes. But anything similar to this formula? Look. The nth root of a to the n and n are similar. N here and n here are same number, exactly the same number. If it's n is odd, then a. If n is even, then the answer equals the absolute value for the inside a. Does I answer your question, Kelly?
Yes, thank you.
You're welcome. Okay, now let's go to the another example, simplifying. So if I give you something like that, simplify this one. The third root of x to the power 4. How I can simplify something like that? The third root of power 4. How we can do that? So look, how can I like do something for this one look like this, number 4?
We take out 3s, one s out and one stay inside.
Okay, perfect. We can factor it, exactly. So how can we factor it? I can like making, here I have the root are equal 3. And here I have 4. Yeah.
X times x to the third?
X times x to the third, nice. So x to the third times x. So now I can use the property number 1. Look at property number 1. Said the nth root for a times b equals the nth root for a times the nth root of b. Same things here. I can make it the third root for the first one times the third root for the second one, right? Third root x to the 3 times third root to the x. What is that equal? What is that equal by using property number 4? Here 3 is odd. This means x. Exactly. You said x times, and this one I can simplify it. No, I cannot. So I keep it the same thing. So this is the answer. So this is equal x. This one I keep it the same thing. Any question? I think no questions. Okay. I give another one. Power 15. How we can think about this one? What is the answer? How can I think about this? X to the power 14. Okay. What else? I can make it like this. X to the power 14 times x. But I have 7 here. Okay, what I have to do? X squared. Can you turn on the mic? You can mic. Angel.
Yeah, I'm sorry, because my brother has music in here. Can put the mic.
Okay.
But it will be s squared to the cube root of 7x.
X equal to 7. Okay. Good idea. Yes. So 2 to the 7. Yeah, like x squared to the 7 times x.
No, it's not to the
Everything.
7. Wait, oh, you're doing something different? Or it will be also.
Oh, how you
Yeah,
think? It's not the same like this?
I was just giving the answer.
What's the answer?
It will be
X
s
squared.
squared root of 7.
Root of 7 like this.
I don't know. I don't know how to say it. It will be s squared times square root of x.
Oh, okay. It's square root of that. The 7th root of x, right?
Yes,
Like this.
yes, that's what I meant.
Okay. So let me check how he think about this. So we know this x to the power 17, I can make it here like x to the 7 times x to the 7. X to the 7 times x to the 7 times x. Because 7 plus 7 is 14. Okay, and this x goes down. So now by using the first property, I separated everything. X to the 7, 7th root x to the 7 times 7th root to the x. What is the answer for this one by using the fourth property? What's the answer for this one by using the fourth property? Is x, exactly, times, and this is x again, times the 7th root of x. X times x is x squared times the 7th root of x. The same like his answer. This is true. Any questions so far? No questions? Okay, let's go to the rational expression. Another part in this section. Rational. So, yeah, Gaussian expression. So we have to know anything look like a to the m over n. We can make it as radical, as look like this. The nth root of a to the n. This is called the rational expression. I can change the look of this one as radical. Or a to the m over n is the same as the nth root of a everything to the m. Here we have to make sure m and n are integer. Both of m and n are integer. And n are integers. And we have to know n here must be positive, not equal 0. Here n positive and not equal 0. So n greater than 0 and also at the same time and not equal 0. N is greater than 0, this is mean and not equal 0. You don't have to write this one. So like I said before, if n is even here, a must be positive. Let me give you an example. So what's the 4 to the power 1/2? By using this strings here, a here is 4, m is 1, n is 2. So 4 to power 1/2 is square root or the second root of the 4. The answer is 2 exactly. Another example. What is 125 raised to the power minus 1/3? What is the answer? Here we have negative. What does the negative mean? Like I said before, negative exponent. Negative exponent mean, like he said, Angel, 1 over 125 to the power 3. To the power 1 over 3. I'm sorry. And what is that equal again? 1 over the third root for 125. What is the cube root? The cubic of 125 is 5. So the answer 1 over 5. Anything? Exactly, Andrew. Anyone has a question? It's nice. No one has a question. It makes sense for all of you. Feeling heavy. Okay, let's go to the next slide. I give you example for simplifying. Simplifying. So simplify this thing, this expression. 2x to the power 3 over 4 over y to the power 1 over 3, everything to the power 3 times y to the 4 to the power 4 over x to the power minus half. How we can think about this one? So like I said before, we're doing this one first, we simplify it. We're doing the first part exactly. Doing the second part, we multiply the both answers. So the first part is 2x to the power 3 over 4 over y to the power 1 over 3. All of these to the power 3. What's the answer? Again, we have 3 here. What we have to do? Distribute it inside the parentheses. Okay? So the 2 to the power 3 times x 3 over 4, everything to the power 3 over y over 1 over 3, everything to the power 3. Okay? What is the what's the answer for this one? So 2 to the 3 is 8. Okay. And here x, he said 9 over 4. Yeah, this is true. And here y over to the 1 over 3 times 3 is y exactly. Why? Because 1 over 3 times 3, this is give me 1. So this is y to the power 1. And the same is y. For the second part, y to the 4 over x to the minus half. I think it's simple already. I can simplify this more. How? I can move this y to the up. How can I move this variable to the up? What I have to do? It is 8 times x to the power 9 over 4 times what? Y to the. When I move this one up, I change the exponent to the negative minus 1. Exactly. I'm going to change the exponent, the sign of the exponent to the negative. So here, y to the power 1 becomes to the y to the power minus 1. Here again, how can I simplify the second part? This is the first part here. This is the second part. How can I simplify it? This is equal y to the 4 times x to the, if I want to move this variable up, I have to change the sign for exponent. So it will be x to the power 1 over 2. Now I multiply this one by this one. So 8 times x minus over 4 times y to the minus 1 times 4 times x to the 1 over 2. So again, I have the same base, x and x, and y and y. So this is mean I can do summation for the exponent. 8 times x to the power 9 over 4 plus 1/2, right? Because they have the same base, times y 4 minus 1 or minus 1 plus 4, doesn't matter. So what's the simple things for this one? Here 9 over 4 plus 1/2, like we're doing in the last lecture. How we can do summation for this fraction.
Same denominator.
Again, what you said?
Same denominator.
I can't hear you. What you said again, sorry.
Same denominator.
Yes, exactly. But here the denominator are different. We have 4 and 2. We try to make the both denominator are equal, or we multiply, cross multiply. So let me do this thing here. This one here. I will do it up. So 9 over 4 plus 1/2. Cross multiply. 9 times 2 is 18 plus 4 times 1 is 4 over 4 times 2 is 8. The answer is 22 over 8. Divide both sides by 2, you give me 11 over 4. Simplify it. So this one here is equal 11 over 4. So the answer for this question is 8 times x to the power 11 over 4 times 4 minus 1 is 3. This is the answer. Any question? Any questions? No question, I think. Okay, last thing I'm going to talk about the section. If we have something like that, example. If the question is 14 to the power over 5 times 14 to the power, I don't know here the question, equal 14 to the power 1. How can I think about this? So when I see something like that, all of them have the same base, 14, 14, 14. This is mean we can add, this is mean we can add the summation, add the exponent together to give me the 1. Okay, this is mean 1, 4, 14, 4 over 5, because they have the same base, plus this thing. I'm looking for this thing. The question is, what is the variable here? What's the answer for this one? The question is looking for this one, this guy. Plus something, I don't know what is that, equal 14 to the power 1. If I have the same base for both sides, 14 and 14, that means the exponents are equal. This is mean 4 over 5 plus this thing equal 1. Okay, so this thing equal, we subtract both from the both sides this fraction. So this equal 1 minus 4 over 5. And I know 1 is equal in general 5 over 5 minus 4 over 5. And this is equal 1 over 5. So the answer is, for this guy, is 1 over 5. Is it 14 to the power of 1 over 5? Yes, exactly. So the answer, so this here, this one here, is 1 over 5. So in general, all the question is, the answer is 14 to the power 1 over 5. Makes sense how I think about this question? Again, if I have the same base, 14, 14, 14, so I try to do summation for 4 over 5 for this guy equal 1, 14 to the power 1. Then, because I have the same base, 14, 14, so 4 over 5 plus this thing equal 1. Now I subtract 4 over 5 from both sides because I want to know what's the value for this guy, taking 1 minus 4 over 5. I do cross multiply, or because I know 1 is the same as 5 over 5. So now I have the same denominator 5. This is mean 5 minus 4 is 1 over 5. So this guy is 1 over 5. Any question? Okay. So we finished this section. Now I'm going to the next section. No questions, right, for this section? Today I'm going to post the web assign for that. I'm going to post the web assign homework for this section today. And don't forget to do the web assign homeworks for the previous section. Okay, let's go to the 1.3. So we finished the 1.1, talk about real numbers. 1.2, talk about exponential and radicals. Now we're going to talk about 1.3, algebraic expression. So in the beginning, we're going to talk for stuff look like this. 2 to the power x to the power 2x to the power 4 plus 3x to the power 2 plus 2x plus 4. This thing is called polynomials. So what is polynomial? This thing here, it's called polynomial. What is the polynomial? So sorry. Okay, polynomials. Definition of polynomials. Polynomials is an expression of form look like a n x to the n plus a n minus 1 x to the n minus 1 plus something plus a1 x plus a0. All these guys, an minus 1, a1, a0 are real numbers. N and n minus 1, n is non-negative integer. I mean non-negative integer, 0 and all the positive integers. Okay, so an minus 1, an, and an minus 1, an minus 2, all these are real numbers, are real. And n, like I said before, is non-negative. So this is like definition of polynomial. So look here, this things look like polynomial. Look, an, xn, an here is 2, x to the power n is here 4, plus an minus 1, an minus 1 is 3, x n minus 1, n minus 1 is 2, and the same a0 is 4, and it's look like polynomial. This expression look like polynomial. So first things in this section, this section, we have to know how to add and subtract polynomial. If I have two polynomial, how can I add what is the polynomial and how I can subtract what is the polynomial? Adding and subtracting polynomial. So I'll explain this by example. Let me give you example. Oh, sorry. Can I move to the next slide?
One second, Professor.
Yeah.
Yes.
Take your time. So the example, let me write it here. For finding the sum. Finding the sum. If I have two polynomials, the first one is x to the power 3 minus 6 x to the power 2 plus 2x plus 4 plus x to the power 3 plus 5 to the x squared and 7x. Sum of two polynomials
will be add 2x to the third minus 1x squared minus 5x plus 4.
Plus 4. I will explain how you think about it. So for a question like this, we try to group, like to make all the variables have the same exponent together. This is the idea. So I have here x to the power 3, and I have here another one, x to the power 3. X to the power 3 plus x to the power 3. Plus, here I have minus x squared plus 5x squared. So I make it together minus 6x squared plus 5x squared plus, this is the plus is 6. Another one, 2x here I have here minus 7x, 2x minus 7x plus, I have here 4 and here I have 0, nothing, plus 4. So all the variables that have the same exponent and make it together. So now x to the power 3 plus x to the power 3. So I have here 1 plus 1. This is mean 2x to the power 3 plus minus 6 plus 5. This is mean minus 1x squared plus 2x minus 7. This is mean minus 5x plus 4x. And here we have 4 only, plus 4. I can simplify this more. I'll do it here up. This is the answer here I give it to you. Is 2x to the power 3 minus x squared minus 5x plus 4. So this is the idea for how to add and subtract polynomial. How to add polynomial. This is the first things about adding polynomial. Any questions so far? Anyone has a question? No? So I'm going to give another example, but not adding. I don't want to add. I want about like I'll give you an example for difference between two polynomials, and I think we don't have enough time, so I'm going to just write down the example, and next time I'm going to start from this example. So here we add two polynomials. This polynomial we added to this polynomial. Again, we make the variables that have the same exponent together, and we simplify it. Okay, let me give you another example, and we're doing this example like this next time. Example for subtract. So the example is find the difference. Homework is due Thursday. Yeah, for the first homework, check the over sign. The over sign, it shows, I think, due Thursday for homework 1.1. Today I'm going to post homework 1.2 due next week. So here, find the, if I give you this polynomial, x to the power 3 minus 6x squared plus 2x plus 4 minus x to to the power 3 plus 5x minus x squared minus 7x. So we're going to do this one next class, Thursday. So we'll stop the class for today until here. Any questions so far about the class? Okay, no questions. Let me stop recording.